Dear students, welcome to a new video for Applied Statistics course. In the previous chapter, we already began our study of probability distribution. We considered three discrete probability distribution: binomial distribution, hypergeometric distribution, Poisson distribution, and geometric distribution. These distributions are based on discrete random variables, which can assume only clearly separated values, and there are gaps in between the values, so it's called a discrete. But in this chapter, we continue our study of probability distributing by continuous probability distributions. A continuous probability distribution usually results from measuring something, such as the distance from home to classrooms, the weight of students, the height of adults. So we have intervals and we have values in a range. When examining a continuous distribution, we're usually interested in information such as the percent of students who travel less than a distance of 10 miles or who travels more than 8 miles. In other words, for a continuous distribution, we may wish to know the percent of observations that occur within a certain range. Of course, it's important to realize that the continuous random variable has an infinite number of values. So you think that the probability of a variable will have a value within a specific range, rather than the probability for a specific value. Now we have a value of a specific range rather than a specific value. Now we will consider the families for continuous distribution, and we will begin with uniform probability distribution, or the family of uniform probability distribution. Here, the uniform probability distribution is the simplest distribution for continuous random variable. Really, it's a simplest form. This distribution has a rectangle shape like this. It is a rectangular shape. So we have a rectangular shape for the uniform distribution. For example, the time to fly via commercial airline from Florida to Atlanta to Greco ranges from 60 minutes to 120 minutes. The random variable in this flight time within this interval, the variable of interest flight time is in minutes, so it's a continuous interval from 60 up to 120. Any values in this range is infinite values, and we want to get a distribution that represents these infinite values from 60 to 120. This uniform distribution is represented by a rectangular in a shape and defined by a maximum point, which is P, and minimum point, which is A, and the height of a rectangular, which is 1 over maximum point minus the minimum point, 1 over P minus A. And we have a form for the uniform probability distribution. The probability distribution form P of x equal to 1 over maximum value, which is B, minus minimum value, which is A. And x, that's a random variable with which we interest, and of course it's a continuous random variable, is in a range in between A and P, in a range in between A and P, and 0 elsewhere. I mean, if it's outside the range, the random variable will considered equal to 0. Now we have two main measures for the uniform probability distribution, which is the mean and standard deviation. The mean equal to mu equal to the maximum point P plus minimum point A over 2, and the standard deviation equal to sigma, the square root for P minus A over to the power 2 over 12. This is the standard deviation of the uniform distribution. Very important topic that, as described in the previous chapters, the probability distributions are very useful in making a probability statements, considering the values of random variables. For this distribution, areas within the distribution is represented by probabilities. We in the previous chapters that we have a random variable discrete, we have a probability for each distribution, probability for getting the binomial distribution, getting the success value, probability of the Poisson distribution in the case of rare events, and so on. Now, in the uniform distribution, a rectangular shape allows us to apply the area formula for a rectangular. So we wanted to find this area because we have infinite number of variables inside this area. For the uniform distribution, the height of the rectangular p of x equal to 1 over p minus a, and the width equal to p minus a, length equal to p minus a. We will multiplying the height of the distribution for by the length to get the interior area, because it's a rectangular, and of course we all know that the rectangular area equal to the height times the base. Recall the geometric lessons before you take P4. Area for any rectangular equal to multiplying the height by the base. The height here is equal to 1 over p minus a, and the base equal to p minus a. So if we multiplying each other, the total area within a continuous probability distribution is always equal to 1. This means that the total area under the curve of the uniform distribution is equal to 1. Total area, not the probability of getting any variable inside this area. Please concentrate and take care of the difference in between the two meaning. The total area of a uniform under the curve of the uniform distribution is always equal to 1. But in sometimes we may interested in a specific area only and the probability of getting this specific area, and we will use it by calculating the area by using the methods and the equations for uniform distribution. So if uniform distribution, for example, from 10 up to 15, this means that the A equal 10 and P, which is the maximum value, equal to 50. The height will be 0.1, which is equal to 1 over 15 minus 10. And we will multiply it by the base, which is 15 minus 10. So the area under the curve, total area, will equal to 1. Now let's take an example to more practice on the uniform distribution. Southwest State University provides bus services to students while they are on campus. A bus arrives at the North Main Street and a colleague drive stop every 30 minutes between 6 a.m. and 11 p.m. during weekdays. Students arrive at the bus stop at random times in this time from 6 up to 11. The time that students wait is uniformly distributed by from 0 up to 30. Number 1, draw a graph of this distribution. We will hear from the examples informations we have that the time of that students wait is uniformly distributed and from 0 up to 30 minutes. So we can draw the graph for the uniform distribution like this. We'll begin with 0 up to 30. In this case, the random variable is the length of time, so the time is measured in a continuous scale, and the wait times may range from 30 to 0 to 30 up to 30 minutes. The graph is like this. This is the base of the rectangular and the height equal to 1 over 30 minus 0. The maximum point, this is this value. Maximum point is equal 1 over p minus a. This is the height for the rectangle. The height for the rectangle, 1 over p minus a. So this value equal 1 over 30 minus 0, which is equal to 0.333. Second requirement, show the range that the area is that of this uniform distribution is equal to 1. Okay, we want to show that the total area is equal to 1. As mentioned before, the area equal to the height times the base. The height in this case was 1 over 30 minus 1 minus 0 times the base, which is ranges from 0 up to 30. So if we multiply the height by the base, we find the value is equal to 1, then we applying the area rule. Number 3, how long will a student have to wait for a bus? In other words, what is the mean waiting time? What is the standard deviation? In requirement 3, we want to get the mean and the standard deviation. The mean for the distribution, as mentioned before in the previous slides, equal to a minimum point plus a maximum point over 2, equal to 30 over 2 equal to 15. This is the mean of the distribution and for waiting time for the bus service. And to find the standard deviation, sigma, the rule for standard deviation for the uniform distribution is equal to the maximum point minus minimum point to the power 2 over 12, which is equal to 8.66, which is the standard deviation of the distribution in minutes. This measures the variation in which the students will wait time. Number 4, what is the probability of a student will wait more than 25 minutes? Please take care. What is the probability that a student will wait more than 25 minutes? This means that the uniform distribution, we will use the area that we are already mentioned for this uniform distribution from 0 up to 30, but he asks for the value from 25, no more than 25. So we will begin at 25 and our upper limit is 30. So the area or the probability that asked about is from 25 up to 30 because this is the values, the 30 is the maximum value that we have. So from 25 to 30, we will get the height in these values and the base. The height is the same because the rectangular is they have the same height, which is 0, 30 minus 1 over 30 minus 0, which is equal to 0.0333. But here, the difference is in the base, that the probability is a part of a rectangular and a part of the area under the uniform curve, not all the area. So we will multiplying the height by the new value for the base, which is 30 minus 25, which is equal to 5, and multiplying the height with the new base equal to 0.1667. So the probability that a student waits between 25 and 30 minutes is 0.1667. This calculation is illustrated by this graph. And the fifth requirement, what is the probability of a student will wait between 10 and 20 minutes? The same for the previous requirement idea, that we have a part of a uniform curve under the rectangular area, not all the area, but the height is the same, only the new value for the base. So the height equal to 1 over 30 minus 0, and the new value equal to the maximum point, which is 20, minus minimum point, which is 10, equal to 10. So equal to 20 minus 10 equal to 10. And if we multiplying the height with the new base under the new requirements, we will find the wait time in between 10 and 20 equal to 0.333. This is for the numerical example for the new form. As you see, it's very easy and very the practice for applying the uniform distribution is very easy in calculation. Please try to solve yourself answering this example or this exercise. You have relatively short life. The length of their life follows in a uniform distribution between 8 and 14 years. You have 5 requirements. Answer it. Try to answer. Try to practice. It's very easy for you. Now we will move to the second important distribution for a continuous distribution, which is the family of normal distribution. Here, the normal distribution have this form. Please don't be bothered from the complex form of the normal distribution. It's very easy. P of x, the probability distribution for random variables that have normal distribution, equal to 1 over sigma multiplied by square root of 2 pi times e to the power negative great brackets and have numerator and denominator here x, which is a random variable, minus mu all to the power 2 over 2 sigma square. Don't be afraid from this shape for the normal distribution formula. It's very easy because you already know all the symbols inside this distribution. Sigma, which is the standard deviation. Pi, which is a mathematical numerical value that is constant, equal to 22 over 7. And E, also it's a mathematical constant in your calculator. And X, it is a random variable that have a continuous random variable for this case because it's a normal distribution and the probability for normal distribution have for the continuous random variables. Mu, it's referred to the mean, and sigma square refer to the variance. So all the symbols inside the normal probability distribution form you already know. But we want to know at the beginning the characteristics for the normal probability distribution. Take care that the normal distribution is one of the most important distributions that depend on it, the mathematical tables and statistics tables and statistical hypothesis testing and many of distributions based on you knowing very much the normal distribution. The normal distribution, first of all, it has a pill shape that has a sine peak and the center of the distribution like this. It's a pill shape like the pill. Okay, so it has a pill shape that have a single peak here only in the top of the center of the distribution, and the arithmetic mean and median and mode are equal and located at the center of the distribution. The three measures of locations, which is mean, median, and mode, are equal and located on the center for the distribution. Half of the area of the normal curve is in the right and in the other half to the left. So the first things or the first most important requirements for a normal distribution that is have bell shape and the one peak on the top of the curve and is The mode and median and mean are located in the center of the distribution. This is the first probability characteristics for the normal probability distribution. The second characteristic for the normal probability distribution is it's asymmetric. It's asymmetric. What I mean by symmetric? That's how we have about the mean. If we have a cut of the normal curve vertical at the center value, they have two halves like the mirror. The same for this equal this. So it is symmetric on the mean. It is symmetrical about the mean. The mean cut the curve to two equal sides from right to left. This is the second characteristic for the normal distribution probability. The third, it falls that is smoothly either direction from the center. Please look to the curve here. It's asymptotic to the here and never cut with this line. Never cut for the horizontal line that gets closer and closer to the x-axis but never touch it. To put another way, the tails extending infinitely to both directions. I mean, this is a tail and this is a tail. So the tail is got closer and closer to the vertical axis, but it never cut with it. So this is the third characteristics for the normal distribution, normal probability distribution. And finally, the location of the normal distribution is determined by the mean. And the dispersion, so we have mu for a normal distribution, and the dispersion or the variation for the variables is determined by the standard deviation sigma. So we have to calculate all the time the mu and sigma to put the two values in the probability distribution form and get the probability distribution for any value, continuous values for that have a normal distribution attitude. Now let's move to another very important types or very important family of the normal distribution. What's meant by family? This means that we have not only one normal distribution, but we have a family of distributions. Let's look to this curve. In this curve, we have a normal probability distribution with equal mean, but it is different in the standard deviation. The standard deviations, that's the height of the pill shape, but the mean is equal. So look to the red line, which is the highest one. Here, the sigma equal to 3.1 years. Then the pill shape, the other shape for the normal distribution with the same mean, mu equal to 20, and the standard deviation here, or the variation of the data, or the dispersion of the data equal to 3.9 years. Finally, the blue curve here, we have also the same mean, but the sigma equal to 5. This is the first type or the first part of a family of the normal distribution. Another part, which is normal distribution having different mean but equal standard deviation. Now we have different mean. Here mu equal to 283, mu equal to 301, and mu equal to 321. But if we look at the three curves, they have the same level for the peak point, and the pill shape have the same level. No pill shape or no curve is more than the other because the sigma is the same and equal to 1.6. So here, in this case, we have the means are different, but the standard deviations are equal. And finally, we have different means and different standard deviations, like this. Here, mu equal to 2000 here, and of course the shape for sigma is differ because its height is differ. We have 3 different sigma standard deviations and 3 different mu. So in this case we can say that we have a normal distribution with different probability different mean and standard deviations. Here we will stop here for identifying what is called by normal distribution, but of course there will be in the next videos another examples and another topics that depend on the normal distribution curve because it's very important distribution, and please practice on this part and solve more exercises from your reference to be professional in applying any continuous distribution. Thank you. Hope you are good luck.